Hi, hello, dear students. Welcome to my session on a very important concept from this structure of atom as well as periodic table. This conflict of deciding atomic number, atomic weight, either atomic number or atomic weight, which should be decided as one of the characteristic property of the element, which gives all the different kinds of properties of elements in the periodic table. That means the physical and chemical properties of the elements are the periodic functions of atomic number or atomic weight. This has to be decided at the time when Mendeleev introduced his periodic table to the entire science. In this, Mendeleev failed in explaining some of the concepts. So that was developed by Moseley's experiment. Moseley's experiment to determine the atomic mass of elements, in which we can say this is Moseley experiment is X-ray spectra. X-ray spectra. He has used the X-rays with anti-cathodes, which are nothing but elements, different elements, and these anti-cathodes are bombarded with cathode rays, and these rays are produced, X-rays are produced with different frequencies corresponding to the different types of elements used in the experiment. And he has produced a experimental result. That result is a graphical representation in which he has taken that frequency of X-rays produced versus this atomic number and frequency graphical representation. He has produced different straight lines for different elements. One line he called as K alpha, another one he called K beta, he called as L alpha, L beta in his experiment. And he given the mathematical relation as square root of mu bar is equals to A into Z minus B as the final relation between the frequency of X-rays produced to that of the atomic number. It reveals that the atomic number must be a fundamental characteristic of the atom. So from this experiment, what we came to know is the X-rays frequency is directly proportional to the atomic number of the atoms, elements. So atomic number is increasing, frequency also increasing according to this Moseley's graphical representations. That's it. We are following the characteristic property of elements as atomic number, and we have prepared the modern periodic table, the original periodic table. Presently what we are using when compared with the modern Mendeleev periodic table is now came into limelight because of this experiment. That is nothing but Moseley's X-ray experiment, X-ray spectra experiment. Thank you very much. So dear students, welcome to this small problem on this Moseley's experiment, that is the frequency of characteristic X-ray of K alpha line of metal target M is 2500 second inverse, and the graph between root nu and Z versus Z is follows like this. Then atomic number of metal target M is what? So we have four options. In this Moseley's law experiment formula, once you observe, square root of nu is equals to a into z minus b. We want to solve this problem means we have to take the help of Moseley's law formula, and in this formula if you try to just write little detailedly, then a into z minus ab will come. If we compare this one with the y is equals to mx plus c, in this the a will become slope. Here what is a? A is slope, nothing but tan theta, already given 45 degrees, so tan theta is equals to 1, tan 45 is 1. That means slope A is 1. Coming to the other aspect, here we have the intercept. What is the intercept here? That is AB, intercept is AB, that is also equals to 1 as per this problem given to us. That is nothing but OA in the problem. Okay, OA, this one. And in this particular case, they have already given the frequency value. If you substitute the frequency value, square root of 2500 is equals to A value is 1. 1 into Z minus 1, so it will become Z minus 1. So square root of 2500 will become 50. That is equals to Z minus 1. It indicates that Z is equals to 50 plus 1, 51. So 51 is the atomic number of the metal target given in the problem. So 51 is the right answer for this Moseley's experimental X-ray spectra experiment question in this JEE-NEET level model. Thank you very much.